If we have any Q&A question, I was told to have a maximum 3 or 4 question. So I'll give first choice to audience. If they have any question, please come back. And question means question. I don't want people to talk what they do. Let's understand from our esteemed technical expert about their project. Do they have any questions, sir?
So we can have all the speakers on stage along with you.
Yeah. No.
And everybody else. Yeah, my question is fairly simple. In the sense, we are all talking about tubes, you have shown big projects and so on. But supposing I have a square tube, a big one, and a small one comes and joins and it is welded, which is quite a common thing to see. But I don't see it. Today, if I have to design that joint, as an engineer, I still have to go to the American code. I don't know if there are any provisions in the Indian code are seriously lacking. Both, if I join two pipes, one to the other, is there any way to calculate the strength of the joint? So I request the Tatas, who are probably influential people, and then there are other influential people here in the steel industry, to press for a better design code. This is my request, that is all. Not, I don't know whether it's a question.
Hello. Thank you, sir, for the right question. I think there is a code called IS 806. It was made 1968, and nobody has revised it till now. And there is a committee CC7. Instag is also part of that, and recently I am also part of that. So that particular code is being modified with help of IIT Madras, and we have made all the drafts. And probably it will be launched very soon. The connection part of it is also covered within that particular code. But as you rightly said, that in India we take a lot of time to do these revisions. That's why probably more than 50 years has passed, but nobody has bothered to change the particular code. So that would definitely help. But if you have any particular situation or scenario or project, so we are using tubes in our own projects. On our expansion projects in Tata Steel in Kalinganagar, where we are using columns and beams with tubes. So if you have any particular problem, you can please share with us. I have a team of structural engineers who are expert in designing with tubes only. So wherever required, we provide that kind of support. So we can do connection design for you as well. So. But that's why nobody is questioning that, because when there is a proper justification of science or technology behind that, so since there is no code, so who can question it? But buildings are standing, and we are using those buildings for very high load bearing, applications. And now railway station developments, every month we are probably producing more than 1,000 ton of 400 sections. And railways, RDSO, they are using those tubes, and they are using connections. So we can do that, sir. We can do that particular support from our end at least, till the time that code is published formally.
Thank you, Amit. I have one question to Professor Jayanta. You have designed the seismic structure. So what are the key learning? Because normally in India, we smaller building or a lower end building, we don't go with the seismic, and we go with the seismic moment we go to high rise or the large. So what are your takeaway from the seismic design when you do? What were the challenges? What the code was challenged, or design was challenged? What was the main challenge you faced?
Code was not much of a challenge. The code is good enough, at least for, but in long span structure, as I said, that dynamic analysis is must. And when we talk about buildings are highly indeterminate in terms of having multiple defense. You have series of columns and beam column joints, and you have a situation where load, moment and shear redistribution is possible. But for a hanger structure, we consider, I just showed in the slide, the hanger structure you could not consider to be having much of ductility, because it is supported on two ends and it is like a portal. So in that case, one has to be very careful about considering the parameters from the seismic code, what response reduction factor I consider in such structures. Because if by mistake somebody thinks that I have done a lot of ductile detailing in my supporting RCC structure, I can take a R value 5, then that could be a disaster. So we took an R value of 3, assuming that the structure will not be that ductile. Steel is ductile, but connection is not ductile. Okay, having the connection ductility is very important, as was mentioned by you, sir. That connection, as you know, in steel structure, the challenge is the designing the connection. The fasteners are very important. The welding is very important. We get the steel, primary steel, the scope design is not very difficult. Even for tubes, we carry out the scope design very quickly because I can model the tubes in a software and I can know what kind of beam, what kind of column will work for my structure, but how to connect them. In case of tubes also, you have challenge of putting stiffener inside, so those challenges are there. I would say for long span structures, dynamic analysis, vertical oscillation is the governing. So the size of the PB girder for long span was governed by vertical component of the oscillation. First fundamental frequency was in vertical, second was in vertical, third was in vertical. Unlike the buildings where it would be in horizontal. So those things should be kept in mind, and once that is controlled, rest of the things will get controlled automatically. Thank you very much.
Thank you. Hello. Mr. Gilbert, a question to you. How did you manage the joint between wood and the steel? Both have a different expansion in the characteristic.
Hello.
Yeah.
Yeah. Actually, what I've done is, if you were to look at the design of the roof, we had sandwiched wood with steel. Actually, the thing is, wood has certain limitations with regard to span and length of the members. So in order to reach the desired length that we want, say for the roof, the gable roof that we had done, we kind of sandwiched wood with steel in the middle. So that way is what wood could not achieve, steel could kind of achieve.
And you get the insulation also. You get the
Yeah, and you get the warmth in the building because, see, I mean, a lot of people have the impression that steel is a very cold material. For residential use, if you were to marry it with wood, I think that kind of brings about the homeliness and the warmth in the building that you're looking for.
Thanks. Mr. Krishnendu, you have done roughly 11,000 metric ton of steel, roughly. What number I was looking at it. So it's almost like a factory inside your whole area. And what was the challenge? It would have been logistically very difficult to do such a large project?
Sir, basically, logistically, it was very, very difficult. That's why that main challenge was whatever I have already told in my presentation, that when we have designed the structures, the very, very architectural sequences are there and very challenging structure it is. So there is a lot of arms are coming from that main part of the trusses. So we cannot transport this through road. So we need to produce that part in our premises only. That was the main challenge, that in the 11,000 metric ton of structures, we need to fabricate in our own premises to make that projects happen. So that was the main challenge. Another challenge was there, that during erection, when we have planned to do how we will do the erection for that particular this type of structures. So when we have planned, in design stage, we have think that when that structure, RCC and that structure connection, that integrity part, that has come in also from architectural point of view, that some certain limitations, so they cannot provide the columns in that particular position to make the structure in simply supported manner. So we have thought when we have made that plan, so erection plan, that one column is standing from that total, if I think one truss, just an example, that truss length is, you think that 70 meter is the truss length, and only one column is there to take that load. And yeah, after erection, all the members of that entire part, there is some flared columns are there, that can be erect only after erection. So we need to design lot of temporary structures to make that in stable position after prior to release the cranes. So lot of challenges are there to make that structure happen, this type of challenges. Another thing is that blasting painting. Blasting painting is the thing that should not be done in a open space. That should be done in a closed forum to maintain that humidity, that lot of controls are there. That SA value we cannot reach if the blasting has been done. Then that very chance to that peeling of that paints. So we have constructed one temporary structures for that, but certainly it is very difficult. We have a lot of the halogens are inside to make that humidity maintained. Another part is that blasting, if you space is constant. So we need to blasting plan, we need to do that blasting plan in night session only. So in night session, when that in cold, in winter, there is basically droplets are there and that wetness so we are facing lot of challenges, these type of challenges. So however, that is a very challenging part and we have done that.
So ladies and gentlemen, in interest of time, if you have any more question, you can discuss with the expert offline. I thanks each and everybody to share their knowledge and wisdom. And thank you very much for this wonderful support.